Welcome everybody to Fusion 360 for civil engineers. For those of you who don't know me, my name is Nick and I'm a final year civil engineering student who recently came off a 15-month internship in civil design at a relatively large company. When I was first asked to do this presentation, I started looking into the best options for quick and concise ideation. I ended up at a software called Fusion 360 by Autodesk because one of my capstone teammates actually used it when they competed in Tchaikovsky's popsicle bridge competition a couple years ago. But we'll go over more of that a bit later. The purpose of this presentation is to introduce you to Fusion 360 as a tool for civil engineers and how to model a bridge in Fusion. By the end of the video, you'll have enough knowledge to model structures of your very own. Before I get into it, I just wanted to make sure you actually have the software installed. So if you didn't have it installed already, feel free to install it now with the link in the description. Make sure to sign in with your institutional information like your school to get a free yearly license for educational purposes. If you're not in school right now, but you still want to get the software, Fusion 360 is also free for personal use for a year. Cool, so now that you hopefully have the software installed, we'll go into what Fusion 360 actually is. So Fusion 360 is a collaborative 3D computer-aided design, manufacturing, and engineering design tool by Autodesk. If you're already familiar with AutoCAD, you already have a leg up and it'll probably be a smooth transition for you to Fusion 360. Typically, the software is used in mechanical and electrical applications, and just for your knowledge, most civil engineering designs and detailed designs are done in either AutoCAD, Revit, or Civil 3D. So you might be wondering what's so great about Fusion 360, which is actually our next topic. The first benefit of Fusion 360 is it's a user-friendly software that introduces you to the principles of 3D modeling. Personally, this is something I would have found really useful before going into more advanced finite element software such as SAP 2000 and ETABS, which you'll eventually be using in your upper year studies and professional career. It's also useful for getting a good understanding of different engineering views, perspectives, and terminology that you'll use for communicating ideas to the people you'll be working with, like other engineers, like mechanical engineers, contractors, and even management. The second benefit is it is quick and concise for ideation. Usually designs take many revisions before the final project is reached, and making changes to a model in Fusion is much quicker than adjusting a bunch of 2D drawings with a lot of small details. Here's that popsicle bridge I mentioned earlier by Team Optimize. They went through a series of iterations on paper, modeled it on Fusion in a couple hours, built it, then went on to compete at the competition 2 days later. Something that's really powerful about Fusion is you can model connections like these dowels here. It's definitely not necessary if you're just sketching some quick ideas, but if you want to go into more detail, the option is there and pretty easy to do. Here's a photo of their bridge getting crushed at the competition. The whole thing was made out of popsicle sticks, white glue, and dental floss. Feel free to pause the video here and take a closer look if you like. The third benefit is that Fusion 360 opens the door to 3D printing, and that generally improves the communication with stakeholders like architects, clients, and contractors. A couple directions you can take 3D printing are for printing smaller scale complex structural systems or connections, structural models for showrooms, or even actual structures. Of course, you could argue that you could just show someone a video of a model, but an advantage of 3D printing is that it actually accommodates different communication styles and offers a more interactive and tactile experience which can improve how your idea is conveyed. Realistically, if you're looking at 3D printing a showroom model, this can lead to significant cost savings because the cost of a typical 3D printer is around $1,000, whereas a showroom model can run you several thousand to tens of thousands of dollars. Here are some 3D printed structures: a house on the top left and a bridge on the bottom right. After learning the fundamentals of 3D modeling in Fusion, you've already covered a good portion of what you'll need to get started with 3D printing. Now that we covered why we're using Fusion, we'll be going over an example of modeling an actual bridge in Fusion. Before we get into the actual modeling, we'll go over some bridge basic terminology that'll help you along the way. If you're just interested in the modeling, feel free to skip ahead with the timestamps in the description. To start us off, a bridge is broken up into three main structures: the substructure, the superstructure, and the foundation. Usually the superstructure and the substructure are divided by the deck. For our example, we'll be focusing on the superstructure and the substructure. Now, the main elements that we want to focus on for the purposes of our example are the abutment, piers, pier caps, girders, and decking. The abutment, as you can see on the left, is on the end of the bridge. Piers are part of a bridge's substructure and support the girders through their pier caps. The girders can't be seen in this specific example, but they usually run parallel to the direction of travel. Finally, the decking is placed on top of the girders to allow for travel. These are the main types of bridges, but of course, it's not all of them. Each of them have their distinct advantages and disadvantages that designers consider when designing a bridge. For our example, we'll be modeling a truss bridge because of its simplicity and load efficiency. It's also a straightforward example that'll introduce you to many of the tools you'll need to make any sort of 3D model in Fusion. Alright, so just to give you a quick recap of what we just covered before we move on to the modeling, Fusion 360 is a design tool that can be used by all types of engineers, and it has three main benefits of being user-friendly, great for quick and concise ideation, and ultimately can lead to 3D printing. The second main point is bridges consist of a superstructure, substructure, and foundation, and the third point is that there are many different bridge types for different applications. At this point, if you have any questions, feel free to leave a comment below. So this is the approach I normally use to design something and can serve as a really good reference point for your future designs. I start my process off with sketching the actual structure with dimensions, then I'll model it and create any presentation material that I'll need. Like I mentioned a bit earlier, we'll be going over an example of a truss bridge, so I created some sketches that we'll use as a reference when modeling. This step is a lot more important than people think, and I would highly recommend taking the time you need to do good work on your sketches and not rush them. Pause the video here if you need to get a good idea of what we'll be making before we continue. And something to note here, I actually made a mistake in the width of the deck. It should be 210 millimeters instead of 220, but you'll see that when we get to the actual modeling. One last point before we get into the modeling is I put together some of the most common commands we'll use in Fusion. I recommend you take a screenshot of this before we begin. If you want to take a quick break right now just to grab a coffee, tea, or some water, feel free to pause the video and we'll jump right in. And to be honest, as I was recording the tutorial, I feel like in the first 5 to 10 minutes, I covered all the commands you actually need to make something in Fusion. So if after the first couple minutes of the tutorial you feel like you got a pretty good handle of how to use the program, then feel free to end the video there and work on some of your own designs. But if you want to hear some of my thought process and how I actually modeled the bridge, then you're welcome to keep watching. And of course, I'll have all the timestamps down below, so if you do feel like you want to skip ahead to just the most important bits, you can go ahead and do just that. So yeah, see you in the tutorial. Alright everyone, welcome back to the Fusion portion of this Fusion 360 tutorial. So like we mentioned earlier, what we're modeling today is going to be a truss bridge, and hopefully you have sketches of your own at this point that you can follow. So what I'd recommend doing, and what I'm actually doing right now, is on another screen to my left, I just have the sketches I made of the truss bridge I showed you earlier. And this will serve as a reference point as we're modeling in Fusion 360. So if you haven't already made those sketches, I'd highly recommend you make those now before going any further. So what we see right here is the Fusion 360 landing page when you start a new project, which looks a little plain. But there are a couple key features I just want to point out before we get into it. So the first feature is in the top right corner here, this cube sort of thing, which you're probably familiar with if you've worked in AutoCAD or any other sort of modeling software. So this cube actually moves and shows you where you are in your model space. And there are three key axes that you want to focus on. You have your x-axis, your y-axis, and your z-axis. And every sketch or component that you're going to be making is going to be oriented based off of these axes or axi, whatever you want to call them. But maybe you can leave a comment below if you know what the proper terminology is. Really appreciate that. But yeah, just make sure you're very comfortable with these axes going forward. So the next key feature that I want to point out is just this toolbar at the top. So you have your create, modify, assemble, construct, inspect, insert, and select. Depending on whether you're on a Mac or on Windows, it might look a little different, but overall, all these settings are the same and they perform the same functions. So there's not too much to worry about there. What you'll be mostly using is what's called create sketch and construct, which allows you to create planes of your own. So let's jump right into the tutorial because I think that's going to make things a lot clearer and easier for you to understand. So starting off, we want to always keep our components and the things that we make in layers. Just like in AutoCAD, the more layers you have, the easier it is to keep things organized and make changes down the line. So how we make a new component is we're gonna right click, hit new component, and the first thing that we're going to be making is a pier. So we'll just type in pier. Maybe we can call it pier 1 or something. From bodies, appearance, that's okay. Activate, okay. So now we have a new component. And how we actually make this component is we're going to create a sketch. So in that top left corner there, you're going to hit create sketch. And this is where the planes and orientation come in. So it's very important for you to understand this concept that every sketch has to be done on a plane or a face. And in our case, we're going to start off by making a 2D drawing on the XY plane. So we're going to click that and eventually we'll extrude that to the dimensions that we need. So the first thing that we're going to do is we're going to hit 2-point rectangle there, or if you want to eventually learn the shortcut, which I highly recommend, you can just hit the R button on your keyboard. And let's make the origin at the origin. So it doesn't really matter what dimensions we put right now because all we have to do is use a tool called the dimension tool. So we'll hit D and let's dimension this length first. So we'll hit D, we'll click again to indicate where we want to put that dimension. And now we'll take a look at our sketch and see what dimension we actually need there. And it turns out that's going to be 100 millimeters. And this top dimension, we're going to hit D again, or you can click in the top left there, sketch dimension. We'll click the edge that we want to dimension. We'll click the location of the dimension. And now the dimension that we need is 250 millimeters. So we'll put that in, hit enter. And now we have this 2D sketch on the XY plane. Now, what we want to do is make this 3D because it's going to eventually be one of our piers or abutments. So to move around, what you can do is hold down the Shift button while hitting your middle mouse button to scroll around and get a different perspective. So you can see this arrow here that indicates the direction that you are extruding in. So if you drag it down, it's going to be negative, and if you drag it up in the direction of the arrow, that'll be positive. And according to our sketch, we want to make that 200 millimeters. So we'll hit 200 and hit enter. So now we have our first pier. And what I would recommend doing is always working in pairs. And what I mean by that is we want to make and take advantage of the mirror tool as much as we can, because that just makes our lives a lot easier rather than doing things twice. And to show you how to do that, I'm going to make a new plane. And the plane that I want to mirror against is going to be this plane, which is our XZ plane. So I'm going to click that plane, and the distance that I want to move it is going to be the midpoint of our bridge. And in this case, according to our sketches, our total bridge length is 1200 millimeters. And what I'd also recommend while you're going through this modeling process is to have a calculator handy so you can do some quick calculations and get your measurements. So half of 1200, we get 600 millimeters, and that's going to be our mirror plane. So I hit 600, and now what we're going to do is we're going to hit S to search, and we're going to type in mirror. You can also drag this icon to your design shortcuts, or you click that button, and now it's just an easy reference to use. So what we're going to do, we're going to click the tool. We're going to make sure the type is a component that we want to mirror, because if you click face, you're just going to be mirroring the face. But in our case, we want a pier on the opposite side of the mirror plane. So we're going to click our component. We're going to click the mirror plane that we're mirroring it against. And if we zoom out with the scroll wheel, we can see that an opaque pier appears on the opposite side of the mirror plane. We're going to hit OK. And now you also notice that it's still opaque, and that's because it's not actually selected. If we wanted to select it, we can just mouse over and click the checkbox over here. And now this actually appears as a solid compared to our first plane. If you want to see all of these components activated, you click the checkbox at the top over there, and now we can see that they're both solid figures. All right, so those are our two piers done. Now what we'll work on next is the actual truss. Now, before we do that, let's rename this pier just so we know where it is. And we're gonna right click, we'll look for rename, let's see, export, activate, new component, properties. Yeah, there we go. Call that pier 2, pier 2. Okay. There's probably a quicker way of doing that, but for now, that will do. And just before we jump into the truss itself, be sure to save your project. So hit Control S, and we'll just call this truss bridge model. All of our Fusion projects are actually saved in the cloud, so most of what we do is backed up, but it's never a bad habit to always save your work in case you have any software issues down the line. All right, so let's get into the truss. We'll right click just like we did before to create a new component. We'll call this truss. Okay, and what we're gonna do is actually work on this green line axis over here, the y-axis. We're gonna click this face called left just to make sure we're flat on the plane. And how I want to start off this truss is I want to find the actual midpoint of it. So we're gonna hit L to create a line, and that's gonna pop up our sketch command, or you can also just click the create sketch over here. We're gonna click the face that we want to draw against. We'll hit the point we want to start at and the end point. Now, this can either be the base of our truss, or you can do what's called a construction line. And if you're familiar with what a construction line is from AutoCAD, it basically just serves as a guide to help you create different objects. So you can either make a construction line by clicking construction here, or you can hit the X command, and that makes your construction line. Alright, so now that we have the construction line, let's make a line at the midpoint just by clicking the midpoint and dragging. And we can also, well, let's turn off these constraints, which we'll get into a little later, just so we can extrude. Okay, perfect. So now that we have made the line a bit longer, we know that this is the midpoint of our bridge. So we're going to start off by making that central member. And ultimately what we're going to be doing is we're going to be mirroring this right side of the truss onto the left side of the truss, and then combining them to make one full truss sketch. So what we can actually start off doing is making this bottom half of the truss. So again, we're gonna hit R. We'll create that rectangle, and again, it doesn't really matter what shape you make it, because, oh, make sure to turn off the construction setting. Turn that off. And now we can dimension. So we'll click this edge, and we know the thickness based off of our sketch is 20 millimeters. And now we know this distance. It should already be defined since we used 2 of those reference points at 600, and that's also the halfway length of our bridge. So now that we have this member defined, we have the bottom member of our truss. And what we're going to do next is we're going to make half of the middle member. So that's going to be another rectangle. So we'll hit R. The height based off of our sketch is 300. And we only want half the thickness of the member because we're going to be mirroring it. So that's going to be 10 millimeters. So there we go. We have our half of the middle member. And the next thing we want to do is we'll make a line at the midpoint of this bottom member, which is going to be our next vertical. And we want to remove these constraints because they don't allow us to extrude properly. So we can see that the line is parallel from that marker that you just saw, and we're gonna this marker, and we're just gonna want to make this into a construction line. All right, so that's the midpoint of where we'll eventually have our vertical member. And now, based off of our sketch, the height of this vertical member is actually, let me just do some quick math here. It's not actually 300. It should be 280 because of the top bar. So make that 280, and because of these constraints here that we set earlier and that are automatically set in some circumstances, we can get this height subtracted from here and having the bar fixed at the bottom there. So we'll draw our next member, we'll hit R, we'll draw a rectangle, and we'll make it the dimensions that we want. So we'll hit D, we want the height to be 280, we want the width to be 20, and a nice feature in Fusion is really the move tool, which is a simple tool but extremely effective. So what we're going to do is we're going to double click one of the outer edges to select all the edges of the rectangle, and then what we're going to do is make sure your item is selected properly and all the edges are selected. We're going to hit point to point. The origin point is going to be this corner here, and the target point let's say will be there. Oh, sorry, I hit escape there instead of enter. So we'll do that one more time, double click, we'll hit M, point to point, hit here. Okay. Oh, another thing to mention is you can't actually select the construction lines as a point because they're technically invisible in the model's eyes. But what happened there is we actually selected this line that is a hard edge and it moved it there. So we'll hit OK. And another feature of the move tool is we can do what's called a free move. So we'll double click our object again, and we know we want to center it in the midpoint of this bottom member. So we'll move this actually minus 10 millimeters, and we'll do it again, hit move, and we'll move that down by 20, just so it's perfectly centered on this bottom member. So now we have our side member for this truss. Now there's definitely more than one way to get something done, so how I did that right now might not be your cup of tea, and I encourage you to find the most efficient way to do things. But for the purposes of this tutorial, these are some of the basic commands that will really help you learn the software, and eventually you might become extremely proficient at the software and have much more quick and efficient ways of doing things. But this is just one way, and it's not the only way. Just wanted to mention that before we keep going. So the next thing that we want to do is make that top member, and how we're going to do that is we know that the top member is going to end here and here. So we can hit R for rectangle, we can start the rectangle there, and we can end it there. Now what we want to do here is we want to dimension this. So we'll dimension that as 20, which it automatically was already, and dimension that as 310. So we have 310 over there. Now we want to make our first diagonal member. And to do that, what we're going to do here is make a construction line that is 20 thick. Make that construction line by hitting X, and we'll also make a line 20 down. Now I'm just making some numbers up here so that it's so that we can make this diagonal, but of course if you have more specific measurements and angles you want to work with, then you can always change your model to accommodate those dimensions. And we're going to do the same thing at the bottom here, so we'll make that 20. Okay. No, not sure what happened there, but it's okay. We'll click that corner, make it 20, hit X for construction line, then again, we'll go 20, X for construction line, then what we'll simply do is connect those corners. Now you can see that we have this middle diagonal member. Now what we're going to do is we're going to make that same diagonal member but on the outer edge. So what we're going to do is we'll do a line that's 20 long and 20 high, and we'll just simply connect it to the edges at the top there. I'm gonna make sure. Now the proportioning is not perfect here. You can obviously do some calculations to make sure it looks a little better than that, but for the purpose of this tutorial and introducing you to the commands, I think we're okay with that. So now we have essentially half of our truss. So what we're going to do now is we're going to select all of the edges that we want to mirror. So one thing to note here actually is the mirror tool that we use in 3D is different from the mirror tool that we use in 2D. So how we get to the 2D mirror tool is we're gonna hit create, click mirror. We have our object selected, and just make sure you have everything you want selected. So that looks pretty good to me. We'll click our mirror line. We'll hit this construction line as our mirror line. We'll hit OK. And now we have a replica of what we just made. So we'll hit E, and then we'll select all of the areas. And we will make this 20 thick. And now we have an extruded frame. So we have this truss now, and what we want to do is we want the same truss member on the other side of these abutments or piers. So what we're going to do, just like we did before, is we first want to construct another offset plane. So we're going to click the plane we want to offset, which is actually, to give you a better angle, this XY plane. So we're going to click this plane, and we're going to offset it to the middle of this pier to make sure that it ends up on the other side. So this distance, we're just going to do some simple calculation. Based off of our sketches, we know our pier is 250 millimeters, and we want half of that. So 125 is going to be where the plane ends up. And now to mirror, we're going to double click one of the faces to select the component. We'll hit S to search for the mirror tool. And if you didn't add a shortcut, you could type in mirror here and get the same mirror tool. But since we have that shortcut, we'll click the shortcut, and we already have the object selected. We're going to click the mirror plane. And if you notice, we can't actually click it because this pier is in the way. What we're going to do is we're going to hide that pier. We're going to hit that mirror plane, and we'll hit OK. And now what we can do is we can show the pier again. Now you might notice that everything is opaque except for our original truss member, and that's because we have it selected with this checkbox. If you wanted to see what the entire truss model looks like, you can hover over this component and click activate. And now we can see the entire truss bridge, with all the components that we made already. Now, looking to our sketch, the next thing I think we should work on is the beams at the bottom of the truss. So what we're gonna do first is we're gonna rename this. Oh, there we go. So we can just double click the name with a slight delay, and we'll call that truss 2. And we'll call this one truss 1. Okay, perfect. So the trusses are done. Now we'll make the beams that are supporting the deck itself. And ordinarily what you would have are piers. So just to give everyone a bit more context of how a bridge design might actually look in a more complicated scenario, is these would be either your piers or abutments. In our case, we're going to simplify the model and call them our abutments. So the ends of the bridges where it's supported. But what you might normally have is also an abutment, or what's called a pier, in the middle of the bridge. And that's going to be reducing your span length in the horizontal direction. And that just means that your deck will be much better supported, and that'll help you with your short-term and long-term deflection criteria. And what normally happens is when you have a pier, you have what's called a pier cap, and I might put some video footage or something over here to better demonstrate what I'm explaining, but you normally have a pier cap that rests on top of your piers, which can be either rectangular, circular, piles or columns, however you want to design it. So what you have on top of your piers are what are called bearings. And these bearings functionality is to transfer load from your girders to your pile cap. And these girders usually run parallel to the direction of travel. So what you would have is a girder that goes lengthwise with the bridge, connected to a bearing, connected to your pile cap, connected to your piles, which bring the loads to the foundation. And just like we mentioned in the presentation, we have what are called superstructure, substructure, and foundation. These abutments and piers and pier caps are all part of your substructure, whereas your truss member, your decking, and even the girders are all part of the superstructure. So that's just some quick information that might give you some more context of how things actually work. But for the purposes of this demonstration, we're just simplifying things, and we're going to throw in a couple beams to transfer the load to the abutments, and also add some additional reinforcement in the middle of the bridge. However, you're always free to design bridges however you want, as long as they're safe. But anyways, we'll go to the top view here, and we want to rotate it just so it's at a better angle for us to work with. And we're gonna make a new component called beams. Now these beams we're gonna want to make in the midpoint of our abutments, and also at the midpoint of where the deck will eventually end up. So what we're gonna do is we'll hit L to make a new line. We want to we'll hide this pier once again. We'll click the face that we want to work with, and it'll move you to this orientation, but that's easily fixed by just rotating it back to something that helps us a bit more. So we're gonna hit L, we're gonna start at the origin, we'll end at the end of the bridge, and we'll make that a construction line. Now what we're gonna do is we're gonna make another line at the midpoint, just so it's an easier reference for us. We're gonna delete this constraint, and we're gonna move this line closer to the middle, so it's an easier reference for us. Now what we can start doing is making the beam at the midpoint of this pier. So what we're gonna do is we're gonna make a line there and make that a construction line. We're gonna make our beam, so we'll hit R. We can start anywhere. This beam is going to be 220. What is that? Oh, we have to change our sketch a little, because initially I used a thickness of 15, but I will update that. We're gonna change this to 40. Okay, there we go. Yeah, that makes sense. So we're gonna hit D. This is gonna be 40, and this dimension is gonna be 250 minus the thickness of our two truss members here, which gives us 210. All right, so now that we have the beam, we're gonna select it. We'll hit M to move, and we'll do a point-to-point movement. So we have the beam there, and we'll hit enter to move it. Now what we can do is we'll delete that construction line. We'll hide this secondary truss, and what we can do is create a constraint from this midpoint to this midpoint, and that'll move our beam to the midpoint of this edge. Okay, so now that we have this beam centered with this edge, we're actually gonna delete this constraint, and not sure what this purple thing is, but we'll delete that too. And we're gonna select the beam, we'll hit M to move, And we're gonna free move this beam actually and move it up negative 20 millimeters to center it on the pier and also between the two trusses. So if we show the truss again, now this beam is perfectly placed between the two trusses. And now we want to add a thickness to it. And since we have the frame ready, we'll hit E to extrude. We'll hold shift and the middle mouse button to, so we actually have to move this sketch up a little, and that's okay. We'll use the free move command again, and we'll move it up 200 millimeters. So it's flush on the face of this abutment. Now we're ready to extrude. So we'll select the beam again, we'll hit E, and we'll extrude it 20 millimeters so that it's flush with the truss. And it doesn't necessarily have to be flush with the truss. It's just, in our case, it works out like that. Now that we have this nice beam here on this pier, what we're gonna do is mirror it onto the other side for the next beam. So what we're gonna do is we'll hit S for our shortcuts. We'll click on mirror. We have our object selected, and normally if you're working on the same components, you could click this mirror plane, but in our case, the origin for our beam component is different from this one. Okay, so what we're gonna have to do actually is create an offset plane at the midpoint of our truss. And if you remember, our total distance was 1200, so we're gonna move it 600 and place it directly in the center. Now we're ready to create another beam on the other pier. So what we're gonna do, we're gonna hit S for shortcut again. We'll click our mirror shortcut. We have our object selected already. Our mirror plane is here, and now that creates the next beam. We'll call this one beam 1. We'll call this beams 2. So now that we have a copy of the beam on the other abutment, what if we want to add a beam to the middle of the truss? And what we can actually do is we'll make a new component, call it middle beam, and click OK. Now we're on the middle beam layer, so we're gonna hit M, create copy, and we'll move it minus 550. And there we go. That's perfectly centered in the middle of our truss. Now that we have the beams here, we're gonna work on the top of the truss. And just to make things a little easier for us, we're gonna hide this, and we're gonna make a new component. We'll call it top of truss. Hit enter. And now we're gonna move to the top face using our handy cube over there. Now, just for simplicity, we're gonna start and end our truss at the end of these points. So what we're gonna wanna do is we'll make a rectangle on this face. We're gonna rotate. We're gonna click the right corner, and we're gonna make our top beam. There we go. Or sorry, top truss member. And just looking at our sketch, we're gonna have 3 of these. So what we can do is we can hit M. What we could do is draw a mirror line, but just for simplicity, we're gonna go to free move and create a copy. We're gonna move this so it lines up nicely with the other side and hit OK. And we're gonna do the same thing for the center. So we're gonna hit select again, hit M for select and move. We're gonna use free move, create a copy, and move that to the center and hit OK. And Now these top truss members are probably at the bottom of the truss, and how you can check is you can hold shift and the middle mouse button and scroll. So just like that, we can verify that they're not actually at the top of the truss. And an easy way to fix that is with our handy move tool. What we're going to do is we're going to hit move. We're going to select that upwards movement, and just from a quick glance at our sketch, that's going to be 500. And that brings it to the top of our truss. Now we want to extrude these top truss members. We're going to hit E, select them again, and we're going to move them -20 for their thickness. There we go, we have the top of our truss. Now that looks pretty good, and if we wanted to look at everything now, we can show all of them and select activate component. Now that looks pretty good to me, and really the only last part that we need is to add in a deck. And now we have a very nice deck for our truss bridge. So if I just show all of the components now, that looks pretty good. And we do have just a slight detail we might want to add to improve it a little. So what we can do is open up our appearance panel to get a lot of different materials that we might want to make our bridge out of. In this case, maybe we want to make the deck out of some sort of textured steel material. So we can scroll down and see that we have a diamond plate steel. So it's super simple. All you do is drag it and drop it onto the component you want to apply the material to, and now you can see we have some sort of texture on the deck, which might help with the friction and improve the safety of the travelers on this bridge. But of course, you can always play around with the different textures, and maybe you wanted to make your bridge out of oak or walnut, pine, whatever floats your boat. You can always click, drag, and drop it onto the component that you want to make that specific material. So we can drag and drop it wherever we want to put it, but for now I want to keep our bridge as a steel bridge. So there you have it. That is our steel bridge in Fusion 360. I hope you learned something new, and just one thing actually before we end this tutorial is you can actually hit render and get some pretty cool views of the bridge itself. So if you wanted to hide these orange squares, which aren't as appealing as the bridge itself, once you click the square, you can see what layer it's actually on, and you can hide it. So let's just hide all of these orange squares. Okay, perfect. So now we'll just collapse all these menus and we'll bring back the pier. So there we are. That is our bridge, and obviously you can play around with all the different type of rendering settings. So again, how you get to that is you just, from the design menu, you click this bubble over here, you can hit render, and scene settings is where you can apply different environments, which are a little fun. You can put in a nice crossroads sort of background, which is taking some time to load. Yeah, let's try this. Settings, background. Oh, there we go. So we'll set it as environment under background. Go back to that crossroads. Then it's a little finicky, but it gets the job done. And obviously you can play around or watch another tutorial of how to get really nice renders in Fusion. But just to give you an idea of how it works is you can apply these different scenes and eventually render them for some really great effects and presentation. So just going back to the design tab, that is our bridge. Awesome, so thanks for getting to the end of the video. I hope you enjoyed it and learned something new. If you did enjoy it, please drop a like and consider subscribing for more videos simplifying construction.